In this video, we are going to look at how to use the techniques that you learned for solving 2-variable linear systems to help solve 3-variable linear systems. And then in our next lesson, we will use those same techniques to solve quadratic systems since we're in the quadratic system. So we're going to use the 3-variable systems to review your 2-variable techniques. I apologize for this box that's around this T here. I'm not sure how to get rid of it, so we're just going to let that go for now. If you need a minute to copy down the problem, pause the video now and do that. We're going to start with our first steps. Now you could do this by elimination or substitution. I am going to do elimination for this, and then when we're practicing in class, if you want to check out substitution, you can ask for help with that. So our first step, or steps, because we're going to do 2 parts to this first step, we're going to do 2 eliminations. To eliminate the same variable, and this is a very important component here. If you do 2 eliminations and you eliminate a different variable each time, you're not going to be able to do the second step. The key here is to pick a variable with a coefficient of 1. In this system of equations, the coefficient with the variable 1 is y. Sometimes you'll have 2 different variables that have a coefficient of 1, so you have to make the choice that you think is going to be the best. I'm going to take the first equation and the fourth equation first. And since I'm eliminating y, oops, sorry, I miscopied. 1 second. We're going to multiply our second equation by 2. That way, the top equation will have a positive 2y, and the second equation will have a negative 2y. And I usually like to write the equations next to. Some people like to do it underneath. That's going to be personal preference, but you do want to keep these extremely organized. So if you're a person that gets a little messy with your work, you have to be extra careful and meticulous when you're doing these. It's very easy to make a mistake, and then that mistake just gets compounded as you go further in the question. All right, so now we're adding, and I would always do adding here. Just makes it easier. The 2y and the negative 2y will cancel. We get 16x plus 11z equals 6. And then we're going to just save that equation for our second step. So I'm just going to box that off and do a second elimination. So I'm going to take the second and third equation, but you could do a different combination. You don't have to do first and second, first and last. You can do different combinations to accomplish your goal of eliminating the same variable twice. And keep it simple for yourself. Use the variable with the coefficient of 1 in both of those scenarios. Now on the top equation I have a negative 3 and the bottom I have a negative y. So to get opposite signs I'm going to multiply by negative 3. That way when I rewrite the top equation I have the minus 3y, and then on the bottom equation I'll get negative 18x plus 3y. So I have those opposite signs allowing me to add. Minus 12z equals 9. Now subtraction is an option. I tend not to take it because it just gets a little more complicated and some people mess up switching of the signs. So to minimize possibilities of mistakes, I would always do adding. Right, the negative 3y plus 3y cancel. That's what we were looking for. We get negative 16x minus 7z equals 2. And that is our second equation with the variable of y eliminated. Now that's important for our second step. Our second step, we are now going to do a third elimination. So do another elimination with the remaining equations. So I'm taking the 16x plus 11z is equal to 6, and the negative 16x minus 7z is equal to 2. This does not work out always this nicely, but the awesome thing about this equation is we don't even have to do any multiplying like we did initially. The 16x and minus 16x will cancel. So we are left with 4z is equal to 8. If that doesn't happen, then you do your multiplying again to do your elimination, not a big deal. And then we're going to solve for the remaining variable. Now this is where when you get to this point, if you get an integer answer, you should feel pretty good, because if you get a fraction or decimal here, you need to go back to the beginning and see where you may have made a mistake. You should get integer numbers at this point. So we get z is equal to 2. And then we're going to take this now and we're going to substitute back in. Now we want to substitute into one of our red equations. And the reason we're substituting into a two-variable equation is to solve for one of the other variables. You can pick either one. I'm going to pick the second one, but it doesn't really matter. So I'll pick the negative 16x minus, and in fact, you know what? Just to highlight that we're using one of those equations, I'm going to use red. So negative 16x minus 7z equals 2. And then we're just going to plug into z and finish solving from there. I forgot the x. And we are also in good shape with this because we get a nice integer answer of -1. So we have two integer answers, feeling pretty good about this at this point. And now we're going to pick one of the original equations to find our last value. Again, it does not matter which one you pick. So I think I'm actually just going to pick the first equation, keep it simple, the 4x plus 2y plus 3z. But you can pick any of the three. You want to pick one that has smaller coefficients, that's fine. And then we're going to plug in what we know. So we know that x is -1, we don't know y, we know that z is 2. And we get our last integer answer of 5. And then your final step is to write as an xyz point. Be careful because we did not solve it and get them in that order. If it helps, you can write xyz here so that you're actually filling in the numbers into their correct locations. If at any point you get a decimal or fraction answer, go back to your previous step, check to see, did you forget a negative sign somewhere? Did you add something incorrectly? Sometimes it's worth just starting over. I know that sounds terrible, but if it's your first number that you don't get right, it's probably worth going back to the beginning and doing the two eliminations again, because it's hard a lot of times to find your mistake otherwise. But you will have time to practice and kind of work through those mistakes, and there will be a good way to self-check as you're going along with a haiku quiz.